All right, so we're going to do this number 1/2. Now, yesterday, let's do some review about this, right? Standard deviation, what is it? It That's the mean. This is our, well, yeah, it's kind of an upside down parabola, right? It's opening downwards, where the mean is the middle. That, now you're talking about a box whisker, okay? This is called the normal distribution, where most of the points, our data points, are going to lie within that 68%, right? And then the other inflection point, two standard deviations, is going to be your 95% of the data points lying there, right? Now, the standard, to figure out what that standard deviation is, it's the average distance of these data points in the 68% that are away from the mean. That's a very difficult thing to measure, right? As we found out yesterday. Okay. All right. The way we do this, we used our formula, which is our little Greek letter here. Keep forgetting what it's called. It's the root of the summation of our data points where I starts with 1 and goes to the number of data points that we have times the x of I, each one of these data points minus the mean squared to avoid square rooting negative numbers. Then we divide that whole thing by n. So the way we did that was we made a table. All right, so let's start with collecting our data points. So I like to put them in order. You don't have to when you're just figuring out the standard deviation and the mean. So to a table. Okay. The first thing we need to know is which data point this is, right? Our x of I. So our first data point, x of 1, the value of that data point, 144. X of 2 is 177. X3 or x of 3 is 215. X of 4 is 221. And x of 5 is 197. Right? The jumbled up little letters. Which ones are scrambled? That's a symbol. That, that's a symbol. You've seen this before. We did Google Sheets. You guys found the columns. You press that button. Okay. I will get to the summation symbol in a minute. Okay. All right. But you do understand that this x of I means each one of these values. So here I equals 1. Here I equals 2. Okay. And we're going to also mean we're we're going to add all of these values together. The sum between 1 and our n happens to be 5. Okay, so n equals 5. Okay. So the first thing we have to do is take each one of our x of I and subtract it. Now remember, this will be represented by x bar 2. It's just a different symbolization. This is actually the mean of the population. This is our purpose. Okay. So we have to figure out this part of the equation. Figure out x of I minus the mean. X of I minus the mean. Okay. So this one, x of 1, when I equal 1, 144. Now, we got to find the mean. We never found the mean, did we? So we got to find the mean. So we're going to add all of these together and divide by n, which is 5. And so let's add them up. 144 plus 177 plus 215 plus 225 plus 197. And before you hit divide by 5, hit enter first, then divide by 5. Our mean is 196. Or I'm sorry, 191 point. So every one of these we're going to have to do minus 191. And that equals negative 47 points. So we're going to do that for each x. This is when I equals 1. This is I equals 2. I equals 3. The values for those 77 minus 191.6, 15 minus 191.6, 225 minus 191.6, 197 minus 191.6. Does anybody have these done? That's our mean. Very good. Okay, so now we've done this part of the equation, right? We did the x of I minus the mean, and we haven't divided by n yet, right? So we've done that part of the equation. What's the next part? Oh, geez, that would help. Huh? What's the next part? We have to square it, right? So let's square them. And the reason why we square them, anybody know? Remember from yesterday? Why do we square them? Yeah, we got to make them positive. We're going to square these. Now, if they don't come out positive in your calculator, you probably did something wrong with the symbolization. Make them positive, okay? Negative 47. Actually, we should put them in front. Negative 47.6 squared, 2265.76. Yes, this is a lot of work, and that's why a lot of you used spreadsheets, because it's a whole lot less work. 213.18. Why are you guys giggling? Yes. Okay, so now we got what? For the equation? So what's the next part? Harlow, this would be what you were asking about. What do you call that? The squiggly thing? Okay, so that just means we're going to sum all of these squared values between 1 and 5. So we're actually just going to take the sum of all of these. That's what that squiggly sign means. Okay, so we're just going to sum these up. And hopefully I can get this done before the end of class. We get 4171.23. So we got the whole numerator. So now we got to divide by n. So now we divide by n, which is 5. We're going to take this, divide it by 5, and we get 834.246. The only thing, now we divide, so we have everything under the radical. The only thing we have to do is square root this number. So I'm going to do second square root that number, parenthesis, enter. My standard deviation is 28.88 or 28.901. Now, what does this mean? This means on our normal curve, my axis, my normal distribution curve. No, you don't have to put this on there. Here's my mean, which is, what did we say the mean was? 191.6. So we're going to add 28.9. That means from a standard deviation of 1, that's going to equal 220.5. And then going the other way, one standard deviation going towards the negative side It's going to be 162.7. So we expect 68% of these data points are going to be in that 60. It's going to be in this plus or minus one standard deviation. Got it? Wonderful. Tedious. You got to be careful.